Again, we have here potassium tetroxalate. So it is titrated with potassium permanganate, and that 1 ml of potassium permanganate is equivalent to 0.111 gram iron. So what would be the normality of tetroxalate as an acid? So these are the given data. We are after the normality of potassium tetroxalate as an acid. So take note that milliequivalence of potassium tetroxalate is equivalent to or equal to milliequivalence of potassium permanganate. However, if you're going to examine the data given, we have only volume of potassium tetroxalate and the volume of potassium permanganate. We do not know the normality, so we cannot solve for the normality as well of potassium tetroxalate. However, we are given in the second analysis from a previous analysis that 1 ml of potassium permanganate is equivalent to 0.11 gram of iron. So we can now get or determine the normality of or concentration of potassium permanganate from this analysis. So first, we're going to determine now the normality of potassium permanganate to solve for the normality of potassium tetroxalate. So milliequivalence of the oxidizing agent is equal to milliequivalence of the reducing agent. So milliequivalence now of potassium permanganate is equal to milliequivalence of iron. Okay. So we are given the volume and we are after the normality. So the formula that we're going to use here is normality times volume. We are given the weight. So, and we do not know volume or normality. So that would be weight of iron divided by atomic weight of iron factor times 1,000. So again, ferrous would be now oxidized to ferric. Okay. So normality is unknown. So again, ferrous to ferric. This will not be given as you should know uh, the value or the factor. So the factor would be equal to, if it is face to face, sana you have to memorize. So it will be oxidized to what? However, as I've said online, so you can just refer to your copies. Plus 3, so that is plus 3 minus plus 2 would be 1. So normality times the volume, which is 1 ml, is equal to the weight 0.111 gram divided by atomic weight 55.85 grams per mole divided by the factor, which is 1 equivalence per mole times 1,000. So you will get here a normality now of potassium permanganate, which is equal to 2 normal. Now, we can make use of this data. Milliequivalence of potassium permanganate is equal now to milliequivalence of potassium tetroxalate. So milliequivalence of potassium tetroxalate, Ktet, which is the milliequivalence of the reducing agent, is equal to milliequivalence of the oxidizing agent. Okay. So that would be equal to milliequivalence of KMnO4. Since we are given the volume, so normality times volume as a reducing agent is equal to, we know already the normality of potassium permanganate, so that would be normality times volume. Normality of potassium tetroxalate as reducing agent times the volume, which is 1 ml, is equal to 2 normal times the volume of 0.2 ml. And the normality of potassium tetroxalate as reducing agent would be equal to 0.4 normal. But we are after the normality of potassium tetroxalate as reducing agent. So we make use again of the formula, normality of the reducing agent, factor of the reducing agent is equal to normality as an acid divided by factor as an acid. So substituting the values, you will have normality as reducing agent, 0.4 normal, factor as reducing agent, potassium tetroxalate. So take note that CO2 oxalate negative 2 will be oxidized to CO2. So that is negative 2, negative 8, minus 2, plus 6 divided by 2 is 3, negative 2, negative 4, plus 4. So factor now would be 4 plus 4 minus plus 3. So the factor would be 1. However, we have 2 carbon atoms here. That would be 2. The factor of oxalate would be 2. Now, look at oxalate as we've discussed from the previous problem. There are 2 oxalates here. So that would be 2 times 2. We'll have a 4, which is the factor. For equivalence per mole, normality as an acid, which is unknown, divided by the factor as an acid, 3 replaceable hydrogen ion. So that is 3 equivalents per mole. So what would be now the value of the normality as an acid? So just substitute, that would be 0.3 normal. So that would be the normality as an acid.